So we're looking at day 2 of trigonometric graphs, and we should be able to anticipate what the graph will look like. Hopefully you can do that with me. What happens to a sine graph with a minus 30 contained in the brackets? Is that a horizontal shift or a vertical shift? Horizontal. Yeah, I'm going to have a horizontal shift. And because it's minus, remember it's opposite. Minus makes me think to go to the left, but it'll actually shift right 30 degrees. What about the +2 on the next one? Vertical or horizontal? Vertical shift. So we're back to the same stuff we had in lesson 2. And that will actually cause the whole graph to move up 2 units. Now in the next one, I have a combination of 2 things. What's the effect of the 60? Horizontal or vertical? Horizontal, left or right? Left. And it's going to go left 60 degrees. And the -1? Up or down? I have that vertical shift on my -1. That's going to make my graph go down 1. Is this number 4 written in a nice format? Okay. And what does the -45 do that's on the left? It moves it up. Okay. So Anthony doesn't mind this 45 on this side. You might prefer it on the other side. But I do have a vertical shift that is going to go up 45 units. And I also have a horizontal shift that is 45. Which way? Yeah. So the negative makes it go right. We can predict that because of our experience with chapter 1 and chapter 2 from this year. In these equations, I needed to have my calculator set in what mode? 1, 3, and 4 needs to be in degree mode. How do I know that? Degree symbol, yeah. In this one, I'm not 100% sure what I need to be in. There's no specification. Can you please produce the graphs that are called for here and state the horizontal phase shift and the vertical shift? So build those graphs, use your calculator, and tell me left or right, up and down. The other. Taking a look at the statements, y equals sine x is a regular graph. There's no phase shift. There's no vertical displacement. The minus on the pi/4, is that right or left? With the minus sign there. It's right. So I have to move right pi/4 units. And in this graph, I would have to be in radian mode. So that's important to note. +5 moves me up 5 units. 3 pi/2 with a plus sign. Because it's pi, what unit does my calculator have to be in, radians or degrees? Radians. So I have 3 pi/2 that's plus. Is that left or right? L or R? Remember, it goes opposite. I have to make a shift to the left 3 pi/2. I don't really like the pi over here. Anthony says he likes it. I prefer to think about the pi on the other side so I can read it off directly. This is going to be a down pi unit. The minus sign is automatically included here. So when it's minus c, it's the same as my minus pi/4. I have to go right C and up D. Here are all the letters I have to worry about, and it's the same thing. I have to go right C, and up D. We okay with graphing trigonometric ratios? Let's turn the page. The policeman statements here are very effective. I think you guys are okay with how to take apart my C's and D's. What we want to try to get today is everything put together. So in the policeman statement at the bottom, we have a large discussion about the parameters of a trigonometric graph. Amplitude, that's how tall the graph was. Period, that's how long it takes to complete a cycle. Remember, we have a formula for period. Period is either 360 divided by b or 2 pi divided by b. We've got horizontal shifts, we've got vertical shifts. Sine and cosine graphs are the same. I like them. Tan graphs are not the same. They have a period that's different. They have a vertical stretch that looks different. And hopefully your calculator will be able to help you with that. So I would have this page open as we take a look on the other side. So we've got this side flipped over. I'd like to go to class example 4 and take that apart. Can you read simply by looking at the equation, how tall will the graph be? What is the period? What is the horizontal shift? What is the vertical shift? Now you can always throw it in your calculator, but now the challenge is, can you figure out what the amplitude is? Can you figure out what the period is? Can you deal with the horizontal shift and the vertical shift? So try out both A and B. They're both set up nicely, and I'll catch up with you. So when we take a look at the equations that were being given, the value at the front gives us our amplitude. Amplitude is really nice to read off. What else is really easy to read off? Horizontal shift is really nice to read off. So I have a horizontal shift that is pi. Is it left or right? Left. I have a left horizontal shift that is pi units. What is this 4 going to do? 4 down. That's a vertical shift of 4 down. Probably the most awkward piece to take apart is finding the period. Finding the period is the coefficient that's in front of the x. In this case, it's factored out. In B, it's factored out. In the next 2 examples, it's not. It's a little more awkward. So my period is calculated by taking 2 pi divided by my B value, which in this case is just 2 pi over 3. And with that similar approach, I have an amplitude. Does this negative affect my amplitude? Not really. It will make the graph look different, but my graph will still be 2/3 tall and 2/3 deep. Horizontally, the shift is coming from here. It's minus. So a minus shift, I think, left, but it goes right. And it goes right pi over 12 units. My vertical shift is up this time. My vertical shift is 3 up. And how am I going to get my period? 2 pi divided by what? 2 pi divided by 1/4. Do you know what that is? That's 8 pi. 2 pi divided by 1/4 is 8 pi. So reading these off has been very nice. We're going to just slide down and get one of these 2. I'd like to look at the sine one, and the cosine one is similar. This equation is not written nicely. The most offensive part of this equation is the 3 is not separated. So you have to factor that 3 out. What's the value of that sauna? Really? Yeah. Well, I mean, cedar itself is expensive, and then if you think about the heats and the other electronics. I don't think your mom's getting a sauna for Mother's Day. No. So this 3 has to come out. I'm going to leave the brackets. The factoring does not affect the 4. What's left? What's left here? That's an x. And what's left with the pi? Pi over 3. Now let's check that out.